Hey everyone, we're back with .NET Conf. So we did a little troubleshooting and it seems like Miguel just muted us. He was all the way down, that's why he couldn't hear us.
Well, I would probably mute me myself too.
You know what? I mute you all the time.
Yeah,
so
I know.
Perfectly fine.
It's true. It's true.
But the content was so good, and I was talking with Cam Sofer, our next speaker, who's right here. Say hi, Cam.
Hey everybody.
So we were like talking behind the scenes, like, well, we'll let Miguel do Miguel stuff, and then we'll come back and go about it. But anyway, now we got Cam here in .NET Conf talking about have your Raspberry, have your Pi. I need it too. Let's talk about that, Cam.
Sure. So before we start, hey Miguel, if you're watching, man, I'm so sorry I had to cut you off. I was really digging your talk. One of the most exciting features of .NET Core is its cross-platform compatibility. So this applies not just to server and desktop environments, but also to IoT devices. Raspberry Pi is arguably the ultimate IoT platform because it packs a very broad range of functionality into a credit card-sized device that's affordable for students, hobbyists, and professionals. So what we're going to cover in this talk, let me share this. Where's my display? There we go. What we're going to cover is we're going to talk about the basics. Where's my slide? There it is. So we're going to talk about developing, deploying, and debugging .NET Core code on the Raspberry Pi. There's a lot less that goes into it than you would think. This is actually going to seem kind of 100 level stuff. Then we're going to talk about GPIO. GPIO stands for General Purpose Input and Output. It refers to this header here on the motherboard. It's a collection of pins that we can use for all kinds of input and output purposes. What we're going to use it for today are some pretty simple demonstrations. We're going to control an LED, and we're going to control a reversible motor. We're going to turn a motor on, and we're going to be able to make it go forward or backward. And then after we play with the GPIO pins a little bit, we're going to take it a step further and use our IoT device on the internet. We're going to integrate a few components with some cloud services. We've got a sensor that we're going to use to alert us when a door is open or closed. And the final thing we're going to do is we're going to control an array of LEDs using Cortana here on my desktop. So with that, let's start at the very beginning.
Hey, Cam, really question. Quick question. Somebody wants to know what version of the Raspberry Pi you're using.
So I'm using a Raspberry Pi 3 Model B, not the B+, although the B+ is a very incremental upgrade over the B. It just adds it's like a rev on Bluetooth, and it adds a power over Ethernet header.
Oh wow!
So we're using the 3B, but the demos that I have out on GitHub, and I'll share that link in a little bit, should work on the 2, the 3, the 3B. I don't know about the 0. I haven't tried it on the 0, but I'd be interested in hearing what your experience is with that.
Awesome, thanks, man.
Sure. So I'm going to jump right into a demo. I'm going to show you how easy it is to get .NET code running on the Raspberry Pi. Now, I'm not going to go through, where to get the Raspberry Pi and the operating system and all that. It's out there on the internet. It's easy to find. We're going to start where I've got a Raspberry Pi device sitting here on my desk. It's connected to my network, and it's running the Raspbian OS with SSH enabled. So all we need to do is write some code. So let's get to it. So I'm just going to pop open a new Visual Studio window here, and we're just going to file new project, ASP.NET Core Web Application, and I'm going to call it PyDemo. I already have a PyDemo folder. How about PyDemo 2? That's creative. I'm just going to take all the defaults, so it's going to be an ASP.NET Core 2.1 Razor web application. All right. So that's done. There's really no need to review this boilerplate. I'm sure anybody who's done an ASP.NET Core application's seen it all. I think I will go ahead and we'll just change some text on the index razor page, just so we can say that we changed it. There we go. And let's run it locally real quick to make sure it works and that I didn't somehow break anything. All right, so it's working, that's fine. Now we need to get it onto the Raspberry Pi. Well, to get it on the Raspberry Pi, I need to package it up as a deployment first. There are two ways we can do deployments in .NET Core. There's a framework-dependent deployment that expects the framework to be installed on the operating system, or there's a self-contained deployment that has all the dependencies along with the executable. I'm going to go with the self-contained deployment, so I don't have to worry about getting the .NET framework, the .NET Core runtime and framework installed on my device. Now, I could package that. We are in PyDemo2. I could publish that, rather, .NET publish -r for to make it a self-contained deployment, targeting Linux-ARM. And that will work. That will do exactly what I want it to. But since I use Visual Studio to build the application, it seems to me like I should probably use Visual Studio to at least publish it before I FTP it out to the device. So let's take a look at how to do that really quick. Just like publishing to Azure, we're going to right-click on the project and go down to Publish. But I'm going to publish to a folder. I'm going to put this folder, I'm going to put it in the root. I'm just going to call it PyDemo2 pub. And then we're going to set a few advanced options. I'm going to go with the debug configuration because I'm going to be showing you debugging here in a minute. Target framework is .NET Core App 2.1. Deployment mode is not going to be framework dependent. It's going to be self-contained. And target runtime, well, you'll notice Linux-ARM isn't in the list. That's okay. I gotcha. We're going to pick Linux-x64, save the profile, and create it. I'm going to go ahead and rename it just so I know what the file name for the profile is. We're going to rename it Pi profile. Now, before I click Publish, I'm going to come over here to the Properties node under the project, and there's a folder for Published Profiles. If we look in there, there's my Pi profile, and this is the profile, and there's the Linux-x64 runtime identifier. I'm going to change that to Linux-ARM. Save it. And now I can come back over here and I can click Publish, and it's going to do its thing. All right, so it's done. Let's see what we got. Where did I put it? I put in C PyDemo2 pub. So there we go. We've got a whole bunch of files in here. We've actually got 355 files in there. But that's everything that our application needs to run on the device. Let's FTP that out there because it's going to take a few seconds to transfer and before we look at the files.
Hey, Cam.
So, yeah.
There's a couple questions in here that people are wondering. Skull Crusher
Sure.
for Life is asking, if you're self-contained, will it package the required dependencies therein, saving space on the Raspberry Pi?
You know, I don't know. All of the deployments I've done, it does seem to grow if I'm doing ASP.NET versus, say, a console. So I'm inclined to say yes, but to be honest, I haven't looked that closely. It is a bigger transfer from ASP.NET, so I'm inclined to say yes, and I'm hoping that somebody has a more definitive answer.
Gotcha, because there's a follow-up when someone's saying, is there a performance difference between publishing a self-contained and framework independent? So I would assume that framework independent would be bigger, though, wouldn't you?
Well, I wouldn't assume there's any type of a performance difference. It's the same. It's the same binaries that are being read in at runtime. It's just whether they're located in the same directory
Oh,
as
got it.
the assembly, or whether they're off somewhere in like a global, like in a path location somewhere.
Perfect. All right. No, it's all good. Go ahead, continue
And
on, sir.
well, I see another question just popped up.
Oh.
Jose wants to know which OS is running on the Raspberry Pi, and that is I'm running the latest version of Raspbian Linux. So yeah, so we're gonna grab this publish location. Where was it? Where did I call it? I probably need to refresh locally. There it is, Pi Demo Pub. And I'm going to connect to my Raspberry Pi over SFTP and FileZilla. FileZilla is an open source file transfer client. I actually have a profile already set up. SFTP uses the same username and credentials as SSH. So when you set up your Pi and you go into the configuration tool to turn on like Wi-Fi and things, you'll also want to turn on the SSH service. Let's make a little location. So you see we're in our home directory for the Pi user. I'm going to make a location to store that. We'll just call it Pi Demo. Actually, Pi Demo 2. There we go. And I'll come over here, Control A, drag and drop, and let it go. And this will take a couple of seconds. It's about 93 megs total with all the dependencies. While that's doing that, I want to come over and I want to actually look in that folder. And we see a lot of things that you would see in a typical ASP.NET Core deployment, right? Like your app settings .json files, and we go down and there's a whole bunch of DLLs and pieces of the framework and compatibility shims for Linux and all kinds of things. And then we get down and we see like we have pydemo2.dll and pydemo2.views.dll. Those are also what we would expect to see in a Razor app. But we also have this file right here, this file that has no extension. Pi-demo2, no extension. That's actually the executable file. That's actually what we're going to run in Linux. There's probably a term for that. I'm really more of a Windows guy anyway, so if there's a terminology there that I'm not aware of, I'd love for somebody to tell me. But all right, so our file transfer is done. So we should, in theory, be able to SSH out to the shell on my Raspberry Pi. And should be able to run it, right? Well, not so fast. Let me go ahead and type in the command, pydemo2, permission denied. If you're not familiar with Linux, Linux has a mechanism whereby we don't just run any file willy-nilly. We have to give files permission to run. And the way we do that is the chmod command. So I'm going to give it permissions. So now it should be able to run. Give it a few seconds to JIT. All right, it's running. Now, I can't look at the website yet, though, because we're running as a Kestrel application. Whoops, wrong zoom it. We're running as a Kestrel application, and Kestrel, by default, if you don't tell it otherwise, is only listening on the loopback adapter, localhost port 5000. So we can change that, right? You can change it in code. We can go to the programs.cs and come in here, and when we're creating our web host, we can add a .use URLs, right? For example. But what we can also do is just at the command line, I'm going to Control C to end the program. And I'm going to run it again, but this time I'm going to pass in a switch, URLs, http:// so every adapter, port 5000. All right, so now we're running and we're listening on all the network adapters on the device. So we should be able to go to my browser, and I should be able to go http:// Raspberry Pi port 5000. Well, that wasn't what I wanted. Why are you searching, Edge? You should not be searching. You didn't search earlier. There it goes. It's loading this time. All right, so there's our website running on the device. So that's really all there was to it. I mean, .NET Core is cross-platform. We really should be able to pick up an application and run it on any platform without any significant changes. Now, debugging the application is where it gets just a tiny bit trickier, but it's still not that difficult. I'm going to leave the application running. I'm going to come back over to Visual Studio. I'm going to get rid of this little change I made. There we go. And we're going to go to Debug and attach to Process. And in the connection type, when you come in here, it's usually going to say default, and it's going to list all your local processes, but we're going to select SSH. And the connection target's going to be your username at the network address. And it'll prompt you for a password. It's not going to prompt me because it's got my credentials cached already. But I'll hit enter. And there's my list of running processes on the Raspberry Pi. And there's PyDemo 2. So we can just attach right to him. It's asking us what type of code we're debugging. So this is managed code. I'm looking at the, while it's attaching, I'm looking at the chat. Yeah, I do have like a foot tall Deadpool character standing here on my desk, by the way. All right, so it's running. Let's set a breakpoint real quick. I'm going to go into the Razor page. And I'm going to set a breakpoint where it drops out of the onGet method. So in theory, we should be able to come back over here to our browser, refresh the page, and hit the breakpoint. So it's going to take a couple seconds this first time because there's a little warm-up involved. But pretty quickly, we do hit the breakpoint. All right, so let's continue. I'm going to hit refresh again. You notice it hits the breakpoint much quicker that time. So that's how we debug in Visual Studio. You can debug in Visual Studio Code too, but there's a little bit more involved. There's a dependency that you have to install on the Pi, and I've got a link to a walkthrough to that on the GitHub page for this talk. I'll be sharing that URL later. All right, so that's pretty much all we need to do to get an ASP.NET Core app running. Now I want to talk about some of the device-specific features of the Raspberry Pi, specifically GPIO, right? Now, before we start talking about GPIO, we have to talk a little bit about, just a tiny bit about electrical engineering. Now, let me preface this. I am not an electrical engineer. There are probably plenty of you in the audience who have way more experience in electrical engineering than I do. I'm probably going to mess up terminology, and for that, I sincerely apologize. Feel free to correct me in the chat or Twitter or whatever. So the Hello World app, when it comes to GPIO, is blinking an LED. To do that, I'm using a few devices here that I want to make you familiar with. The first one is this little blue thing right here. On my device, it's black on one. I think it's green on another one, but it's called a cobbler or a breakout board. The idea behind this cobbler or breakout board is that I can hook on the Raspberry Pi itself a ribbon cable that connects the GPIO header to the header on this cobbler, and then plug the cobbler into a breadboard, which makes it easy to connect wires to these various pins on the Raspberry Pi and have a visual representation of what I'm connecting to. Now, the breadboard itself, if you've never used a breadboard, and breadboards were new to me until recently, the breadboard itself is a device that's used for prototyping circuits without doing any soldering, which is really handy for me because I'm awful at soldering. So the way it works is all these ports on the breadboard are connected to other ports. On the edge, we've got ports running down the length of the device. And in the middle, we've got ports that run on either side of the median. And what this allows us to do, like I said, is to plug our cobbler into the breadboard and then use jumper wires and kind of play operator. You remember the old cartoons where the operators would plug in the plugs into the switchboard, and it's kind of like that. Again, I'm not going to go into the circuit or why the LED works or why there's a resistor there or anything like that. But what's important is to know that to turn on the LED, I need to turn on GPIO 17. That's pin 17. I just arbitrarily picked pin 17. There's no reason to pick it over any other one. I just arbitrarily picked that one. And it feeds power to this rail down here on the bottom, which feeds power to the resistor, which feeds power to the LED, which is connected, the cathode, the out pin on the LED is connected to this row right here, which goes back to the ground pin on the header. So that's the circuit. Now, before I show you the code that's going to run this circuit, I need to show you a feature of the Raspbian operating system that's fundamental to how the code works. So let's drop out of the slide here. And I'm going to go back over to my shell. And what I want to show you is a virtual file system location on the Raspbian operating system. So this /class/GPIO. And what this file system location allows us to do is it allows us to control our GPIO pins directly through the shell. Let me demonstrate. So if I look at the contents of this directory, we have a few different locations. We have locations named export and unexport, and we have 3 representing GPIO chips. We're just concerned with export and unexport at this moment. Now, to open pin 17, I'm going to write the text 17, and I'm going to pipe it to that export location. So now if I look at the directory contents, notice that I have right here a GPIO 17 location. So if we change our directory to GPIO 17 and look at the contents, we have a few other locations, and what we're concerned with here are direction and value. So whenever we open a pin, we need to set a direction. We need to tell the device whether to generate current or expect current coming into the pin, like a ground pin. The way we do that is we just write a text value, and in this case, out. We want the pin to generate a current. Echo out to direction. All right, so direction is out. And then we can turn on the LED, turn it off and on by writing 1 or 0 to the value location. And to show you an actual breadboard with the LED, I've got a little camera rig here. I actually had to do a little bit of a Rube Goldberg contraption where I'm remoting into another machine driving the camera because Skype does not like this camera. And you can see that this circuit is exactly the same as it was on the schematic I showed you a second ago. I mean, I've got it plugged into pin 17, the blue wire, right down to the wire color. I really wanted to make it so you could reconstruct this at home without too much effort. So yeah, we should be able to just write 1 to the value, and it should turn the LED on. Let's try it. Echo 1 to value. And there we go. We turned on an LED. Now let's turn it off. There we go. And then we can close the pin by echoing 17 to unexport. All right. If we look at the directory again, 17 has been closed. So how do we do this in .NET? Well, there are APIs to do it, certainly. Now, I did not use any of the other APIs that are out there, and we're going to talk about that later near the end of the talk. I actually rolled my own. And this GPIO.net project in the demos folder on the GitHub repository for this talk has a GPIO pin class. Now, in that class, we just have 3 properties: number, direction, and value. And we'll come back to the getters and setters for value here in a second. When we initialize the object. We are requiring a pin number and a direction in the constructor, right? And we're setting those right off the bat. And we're writing those out to that location. So we're opening the pin. Then later on, we're setting the direction. And then we're setting a default value, right? So we have an optional parameter on the constructor that sets a default value of pin value.low. Wait, low? What's that mean? We talked 1 and 0. Well, in GPIO terms, high is 1, low is 0. I don't know why. All right, this goes back to me saying I'm not an electrical engineer. I'm sure somebody in the audience can probably tell us why. But that's the terminology, so that's what I went with. The other thing that this class does is, in the event that we set pin direction in other words, we're expecting current, so we're going to watch to see if the circuit is broken. I kick off a task, an asynchronous task that I call pin watcher, that just actually polls the value every 10 milliseconds and fires off an event if the value changes to either high or low. Why am I polling there? Why didn't I use like a file system watcher? Well, I tried using the file system watcher, and it doesn't like that virtual file system thing. So I had to use kind of this hacky kludgy method. There is an API out there that will do it kind of the right way, directly in memory, but it's not quite baked yet, and we'll get to that. So my Hello World LED program, where was the code for that? There it is. All it does when we run the code is it's going to new up my GPIO pin class with pin 17, direction out, and we're going to loop 5 times. We're going to turn it on, wait a second, turn it off, wait a second. That's all we're going to do. Now, GPIO pin, it implements iDisposable because I made it, I wrote it in such a way that it is considerate and closes the pins that it opens. So we want to use the using pattern to make sure that we dispose of it properly. So with that, I've already got it built. I've already got it deployed. Let's just go ahead and run it. Let me get the breadboard up where we can see it. There we go. And sure enough, it works. All right, so on one hand, hey, that's pretty cool. We can control an LED through hardware that, you know, kind of like low-level on-the-metal hardware. But on another level, big deal. We turned on an LED, right? Well, that little piece of functionality, being able to open and close a pin, open and close a circuit like that, opens up a whole world of possibilities for us. Let me illustrate. The next demo I'm going to show you is this circuit. Now, I realize this circuit looks kind of nasty, has lots of wires and relays and things like that, but it's really not that bad. I'm actually switching out my breadboards while I'm talking. So I've got 2 relay modules attached to my breadboard. And what we need to take away from this is that the first relay module, the one on the top there, it's only using one of its 2 relays because these are dual relay modules. It's connected to pin 21, and all it does is open and close the circuit, turn this motor on and off. That's all it does. Now the other one, the second relay module, has 2 relays on it, and we are actually using both of those. But what I want to point out is that they are both hooked up to the same pin. In fact, let's zoom in a little bit there. You can see those are both hooked up to pin 27, both of them. Now, why would I do that? Well, the reason I did that is because I wired this circuit in such a way that when these 2 relays on the second relay module are turned off, power flows one way through the circuit. And then when we've turned them both on at the same time, we use a different set of wires, and power flows the other way, reversing the polarity of the motor. Okay? So we're going to, I see somebody likes my zooming. Oh, it's Scott. Hey, Scott, you like my zooming skills, huh? So I'm going to switch out. Let me plug in this breadboard. really quick. This breadboard is exactly what's on the schematic I showed you, right down to the wire color. I paid a lot of attention to detail. I 3D printed a little bushing to hold my motor so we can make it more visible for you. And I put a little spinner on the shaft, so when the motor's spinning, you have a visual representation of it. So let's take a look at the .NET code that goes along with that real quick before we run it. This is the motor project in the demo solution. We'll start with the motor class. The motor class is actually really simple. When we new it up, we pass in the constructor a power pin number and a polarity pin number, and we new up those GPIO pins. And notice we set a default value of pin value high. Why on earth would we do that? Well, it has to do with the way the relays are expecting current from the device. It turns out that my relay modules expect pin value high to be on and pin value low to be off. It's just how the relay modules were designed, so I'm just rolling with it. So when we call on, we set pin value to low, turns the motor on. When we call off, we set high, turns the motor off. And then I just arbitrarily chose high and low for forward and reverse. The program code that launches that motor class, I just made a little command line interpreter, right? So it news up the motor using the using iDisposable pattern again, and sits in a loop looking for commands: on, off, reverse, forward, and exit. And those are all pretty self-explanatory. So let's go ahead and run it. Need to put the breadboard where you can see it. There we go. Yep, I know it's a directory. Executable, please. There we go. All right, valid commands: on, off, forward, reverse, and exit. So let's try on. Motor's spinning. All right, let's reverse it. All right, it's going the other way. Let's go ahead and just turn the motor off. So you'll notice it's still reversed, and the relay that controls reverse and forward is it works independently of the relay that controls on or off. So we can set it back forward again, turn it on again, and off. So that's a practical application beyond just turning a light on and off. We can actually turn like physical things on and off. Motors, you could connect relays to lamps. These relays actually support up to 15 amps on a 110 volt circuit, so you could control your household lighting with one of these if you were so inclined. All right, so we've put the things in Internet of Things. We've been looking at the GPIO pins, but this is everything we've done so far has been constrained locally to my Raspberry Pi right here on my desk. What I want to do now is I want to show you a few projects that I did to give you some ideas of things that you can do with this using some services out in the cloud. And to start, I'm going to dive right in with that door alert sensor I told you about. Now let me switch out my breadboards. Bear with me for a few seconds. All right.
Hey, Cam.
So what I've got now.
Hey, Cam.
Yes.
Everybody's loving you. This is amazing. You're doing a great job,
Thank you
man.
so much. I appreciate that. You never know how a talk is going to be received until you do it. And this is a brand new talk.
Hanselman feels threatened. I mean, this is up there.
I appreciate that. All right. So what I'm going to show you now is we're actually going to use pin direction in, right? We're going to watch a circuit to see if it gets, to see if it's opened or closed. And what I'm using are these little magnetic, this little magnetic reed switch. So the whole idea behind a reed switch is when the magnet is present, the switch is closed, so the circuit is connected. And when the magnet is not present, the switch is open, so the circuit is disconnected. And let me zoom in a little bit here. so I can show you. You can't really make out the text on the breadboard, but the blue wire is 3-volt power, and that's going to the reed switch. And then pin 20 right there is that's going to be in. That's going to be what's watching to see if the power is coming into the pin or not and firing off events in our code. So let's look at that code real quick so we understand what's going on. This is the door watcher program. So I'm going to skip right down here to main, and all I'm doing is I'm newing up that pin on port 20, direction in, and I'm wiring up a couple of events, contact switch high and contact switch low. If we go look at those two events, they both do practically the same thing. They pass a message off to a method called post status. And what post status does is it kicks off an asynchronous task that serializes a message. And if you're wondering what that looks like, there's not much to it. It's just a single property on that class. It serializes that message to JSON, and it posts it to an Azure Logic app. Now, I chose an Azure Logic app for this because they are dead simple to set up. We can go look at it real quick. This is the Logic app. It has a single trigger and a single action. The trigger is just an HTTP webhook. So you saw back in the code, I'm posting to a HTTP location. And there's the schema for the message that matches the class in my project. And then what it does with that message, there's a billion different connectors that we can choose from in Logic apps. I chose Slack in this case just because it would be easy to show here on the screen share. But you could use something like Twilio. You could log it in an Excel spreadsheet. If you want to know who came and left your office all day, you could set that up. Not who, but what time people came and left, and when the doors opened. You could rig up a home security system. You could do stuff like that and make it go to your phone, go wherever. That's kind of the magic of something like Logic apps. So let's look. You can see where I was actually trying this earlier. I meant to reset this. This is my Slack room right here, and go back to the GPIO. Let's move this over here. And I exit my motor program. Whoops. There we go. And let's run the door watcher program. All right, so now it's waiting for the switch. So you can see up in the breadboard, I'm going to put the magnet next to the switch. It's going to take a few seconds to wake up the Logic app the first time. But after that, it's basically sub-second. So there we go. There's a home security system made with a Raspberry Pi and a $5 reed switch. Okay, now for my final demonstration of cloud integrations that we can do, I want to actually use Cortana to drive, like I said, I have an array of LEDs that I want to be able to instruct Cortana to turn these LEDs on and off. There's a problem with this, however, and I've got a slide to illustrate that. The problem is that the way this is going to work is I'm actually going to do this with the Cortana integration on if this then that. It's a service. It's a lot like Logic apps. It's a lot simpler though. It has a single trigger and a single action. If A happens, then B. And Cortana actually has some actions out there that are pretty robust, that are really easy to use. I'm going to show you that here in a second. So my thought was, well, we could trigger Cortana. We could invoke Cortana. .NET Bot is going to help me with that. If I can ever click, there we go. We're going to invoke Cortana, and that's going to set off the trigger in IFT, right? And then IFT could maybe fire off a webhook to hit a web API on my Raspberry Pi, right? I mean, that seems to make sense. The problem is we're here in my home office. We're behind my firewall. I could open a port on my firewall, but I'm not going to do that. What if I was in a location where I couldn't open a port on my firewall? So the traffic's not going to get through, and that's not going to work. So we have to come up with another solution. So the way this is going to work is we're going to use a couple other services. We're going to use an Azure Logic App and an Azure Service Bus message queue. And the way it's going to go is when we first start the application, it's going to make an outbound connection from behind my firewall to the message queue, where it's going to watch the queue, and it's going to wait for new messages. Then at some future time, we can invoke Cortana, which will fire off the trigger on if this, then that, which will use a webhook and post that webhook on another Azure Logic App, which that Logic App will in turn create a service bus message and put it on the queue, where it's immediately picked up and acted on by our application. All right, so I'm going to walk through all the code on that, and then we're actually going to demo it. Let me close that. So let's start with the service bus queue. There's actually nothing to the service bus queue. I already have a service bus namespace I created. I just took all the defaults, and then there's 2 queues I put in there. I had one for another demo that I am not going to be doing, and I have this one here called Cortana. It's all default. I made no changes whatsoever, just file new basically. Now the Logic app, let's check out that Logic app. That Logic app, again, is pretty simple. It's pretty much the same as the other one. We've got a webhook here, right, with a simple schema that's expecting a single property called color. And the action that Logic app is going to take is it's going to send a message to a service bus queue named Cortana, and I've already done all the wiring up, and it walks you through it the first time you set it up. Okay, so that's the 2 Azure components. That's the service bus queue and the Logic app. Let's go look at the .NET code really quick. Don't do this, by the way. Don't hard code your connection strings. I was rushed. I was rushed. You put your connection strings someplace where they belong, please. So what we do is we open up these 3 pins, and then we connect to the service bus queue, and we watch it. We register some handlers to handle the messages as they're posted. And then we just say, okay, we're waiting for Cortana. Now the handlers are actually pretty simple. They're very similar to the Door Watcher app, actually, the same kind of thing, where all we're doing is we're looking at that message, right? And first thing we're doing when we get down to the process color text, it has to go through several levels of process messages and handlers and so forth. But when it gets down to process color text, we're just looking. If it's red, we turn on the red light. If it's yellow, we turn on the yellow. If it's green, we turn on the green. Again, you're going to say, okay, but why is this pin value low and not pin value high? I'm going to explain that in just a second. This one's actually pretty easy to understand for me anyway. And then if it's not red, yellow, or green, we're going to blink all the LEDs as kind of an error state to say, hey, yeah, this isn't a color. You asked for purple, and we don't have purple. So the final thing that we need to do to get this all wired up is we need to set up Cortana. And she thinks I'm talking to her. Hold on. There we go. So I've logged into my IFT account. We're going to make a new applet. We're going to say if this, and this is going to be Cortana. And we're going to say a phrase with text. What do you want to say? I'm going to say turn on the, and then you see it says down here that the $sign is the token for the text ingredient, they call it. So the text that we want to pass on to the to our action. So we're going to say turn on the $sign light. Also just add $sign light please as another option. And what do I want Cortana to say in response? How about we have her say, sure. I'll send a message to turn on the $light. So there's our trigger. Yeah, I see out in the chat they're asking where's the device integration. This is poor man's Cortana integration. You're absolutely right. We could write Cortana code to live on a Pi device using Windows IoT, but this is more. I'm going to use some integrations from my desktop here to automate stuff like in my house or office or whatever. So the trigger was Cortana, and then that is going to be in this case, another webhook. We're going to make a web request, and I have my webhook URL over here in my notes. Authentication is baked into that URL, has I believe an OAuth token in it. Going to post application JSON, and then what we're going to post, the shape of that message is, whoops, wrong. Copy and paste. There we go. That's the shape of the message, just a single property called color. And I don't want notifications. So there we go. We made a new applet. It's all wired up and ready to go. The only other thing we need to do is we need to hook up the breadboard that has the LEDs. So let me do that very quickly. There we go. Now, I told you that the reason that there's a very easy to understand reason why we're using low instead of high to turn on these LEDs. And that reason is the, what's the hotkey for a line? So the 3.3 volt wire here is going to this rail, which is providing power to all of these resistors, which are in turn providing power to the LEDs. And then the cathodes from the LEDs are connected to their respective ports. Since the cathodes, the outputs from the LEDs are connected to the ports are going to be blocking the connection when they're high and when they're set to 1, but they're going to be allowing the connection when they're set to 0. So that's why low is going to turn them on and high is going to turn them off. You'll notice also the red and the yellow happen to be glowing a little, and I think the green is too. It's just not coming through on the camera. That's because we haven't opened the pins, and there's just a little bit of background voltage flowing across the pins yet. When we open the pins in the Raspbian operating system, you'll see that that little glow will go away. So let's just go ahead and run it. It should all be wired up and ready to go now. All right, so let's try this. Hey, Cortana, turn on the green light.
Sure. I'll send a message to turn on the green light.
There we go. It was that quick. Let's try it again. Hey, Cortana. Oh,
that's me.
Yeah, sorry. I clicked when I shouldn't. Hey, Cortana. Or I'll just click. Turn on the yellow light. Well, now I've gone and confused her.
Sure. I'll send a message to turn on the yellow light.
All right. Let's try a color that we don't have. Hey, Cortana. Turn on the purple light.
Sure. I'll send a message to turn on the purple light.
I don't know how good the frame rate on Skype is, but you should have seen all the lights blinking in quick succession to show that we don't have a purple light. One more thing I want to try. Hey, Cortana. Hey, Cortana. Oh, she heard me say hey, Cortana twice. My poor little Surface is I can just hear the CPU burning. I'm just going to click the mic. You don't have to put on the red light.
Ken, I'm not Roxanne and you're not Sting. And that's a really lame 80s music joke.
For those of you youngins, that was a joke about the Police. They were a really cool band in the 80s, and you should go check them out on Spotify. All right, so that is it for our integration demos, which leaves us one more point of discussion. And that point of discussion is, what now? Well, I encourage you to go check out my GitHub. It's at that address right there, github.com/camsoper/haveyourpi. There you'll find my notes with everything you need to know. I've got links to where you can get the operating systems and some advice about which devices to buy and which components to buy to build these. I've got all my schematics, all my demos, including some demos that I didn't use, and all these slides. I'll also put a link to this talk on that GitHub so you can refer to it in the future. The other thing I wanted to talk about is you should go take a look at system.devices.gpio. That is a package that is currently in pre-release. It is targeted for .NET Core 3.0. It is very early in development, and the API surface is very likely to change before release. It's designed for all kinds of IoT platforms that use GPIO, Raspberry Pi included, and it's kind of an easy one to feature because it's so ubiquitous. There's actually a reason why I didn't use system.devices.gpio. It mostly works, but the demo that I had where we were watching the read sensor, it locked up my Raspberry Pi pretty consistently every time I demoed it. So I ended up not using it, but it is, like I said, early pre-release, and it doesn't use that kind of hacky mechanism that I used in the file system. It does support pulse width modulation, so that's the ability to kind of ramp up and ramp down power on a pin. So you can make LEDs, for example, you could make LEDs brighter or dimmer. And it also supports SPI and I2C, which are serial interfaces for talking to things like temperature sensors and humidity sensors. Finally, the team has asked me to point out to you guys that they're looking for contributors. If this is something that you're really interested in and this is in your wheelhouse, by all means, go check out their GitHub and send them a few pull requests. So with that, I'd like to see if we have any other questions.
Hey, Cam, I think everybody's afraid of asking questions. You just literally dropped the virtual mic here. Everybody's been loving it. The demo was on point. I mean, like Hanselman said.
Like literally, if I'm a little bit bro crushing on you, my friend, just FYI, just have that in the back of your mind while I'm saying this. But like, IoT demos are hard because I'm literally sweating bullets that things will not work, but everything worked amazing for you, bud.
Yeah, you did. This is awesome, man.
Dang.
Well, thank you. I appreciate that.
Yeah, everybody.
So if there's not,
go ahead.
I was just going to say, so if there aren't any more questions, I just want to say I hope everyone found this informative and enjoyable, and I really hope you found yourself inspired with some ideas to go implement in your own Raspberry Pi projects. You can, again, check out my GitHub, check out my Twitter. You can always hit me up, and I'll try to help you out. And do check out the system.devices.gpio project, because that is going to be the official .NET Core support in the future.
Nice.
Awesome. Thank you so much,
Well,
Cam.
I'm Cam-spired.
It's a good thing we're in the afternoon now.
That's right. That's right.
We're rounding down.
And I heard I'm too loud, so I will keep it
Cam,
down.
Thank you so much for taking the time talking to us. Everybody, we're going to go to a quick break, learn about functions in Azure, and then we'll be right back with Jeremy, our next presenter. Thank you so much.